Chapter 8, Part 2, Other Threats to Internal Validity of Between Subject Designs. There are other threats to internal validity. One is a differential attrition or mortality. Differential attrition happens when the attrition rate in your experimental group and control group is not the same. For example, you're comparing two dieting programs. You start with 50 participants in each group, but one group has a lot of attrition and the other one doesn't have. So you end up with like 4 participants in one group and 49 in the other group, which are not comparable. Another factor is the diffusion of treatment. This happens when participants in one group get a chance to communicate their experience with the other. So you're comparing like two teaching methods, and then your participants go and talk to each other during your experiment, and they learn some of the tricks or the treatments that the experimental group was only supposed to know, and that's gonna change the results of your research. Another factor is compensatory equalization, which, like I said before, this happens when you have special treatment for your experimental group and the other group, which is the control group, although they don't get that treatment, but they somehow get something or do something that makes them comparable or equal to the treatment group. And finally, we have the compensation rivalry, which happens when your control group performs over their regular performance. They do their best, they work hard, they practice a lot, because they know they are being compared with an experimental group. And of course, this is going to change the results and your conclusion. And finally, we have the resentful demoralization, which is the opposite of compensation rivalry. When control groups see that the experimental group is receiving a special treatment, they lose their motivation to work, and they even underperform their regular performance. And this is again another threat to the internal validity of your research. Now, after you do your between subject research, what statistical analysis should be used to see if the difference is significant? The easiest statistical analysis is the t-test if you have only two groups. So you have to use independent sample t-test in order to compare your experimental and control group. The good thing with using two groups and t-test is that it's easy to have only two groups, and also because you have only two groups, you can use extreme values in terms of like your treatment. You can maximize the strength of your treatment to make sure that you're going to see or find if the treatment is effective. However, if you use only two groups, you're losing the whole picture. You're missing the whole picture. You don't see different levels or different intensity of your treatment, how it's effective. For example, as you see in this picture, depending on how many dosage of your medicine you give to your participants, their activity level is different. So if you just compare two conditions or two data points, you may see an imperfect picture of your treatment, and you don't see the fact that if you go over a specific amount of that medicine, the performance is going to actually go down. There's also a possibility that sometimes you have more than two groups to compare, or you have more than two conditions to compare. For example, if you want to do a research on the effectiveness of using a cell phone in a car on driving errors, you may have only two groups: cell phone, no cell phone, or you may have three groups: one group no cell phone, the other group has cell phone uh, but talking only, and the third group with the cell phone and texting. So if you're dealing with this situation with more than two groups, then you cannot use t-test and you have to use ANOVA. ANOVA is a statistical analysis that's used for comparing the means, the average of uh, groups when you have more than two groups. However, you should know that ANOVA only shows the overall effectiveness of the treatment, and it doesn't compare uh, different data points or different specific pairs like group A with B, group B with C, group D with B. If you want to do that, then you need to do a post hoc analysis like Tukey test or LSD or Shefay in order to do those pair comparisons later. The good thing with the ANOVA is that it shows a whole picture or a full functional relationship between variables, and that therefore it's considered a stronger evidence to show a real cause and effect relationship. Finally, there are situations that you cannot use either t-test or ANOVA, and this situation deals with nominal or ordinal variable. There are situations that you don't have a real score or a real test for your participants. All you have is nominal scale. In this situation, you have to use a statistical analysis called chi-square. So in order to do the chi-square, you have to make a table like this, and you have your independent variable in one column, and then you have your dependent variable here. However, because you don't have any score or grade, you just put the number of participants in each condition. For example, in this table, you see you're comparing different teaching methods. So there are 5 people in the traditional method who passed the test, and there are 6 people in the traditional method who didn't pass the test. And then you do the chi-square to see if there is a significant difference between these 3 teaching methods.